Good evening, dear students. So we are discussing here the important concepts from the science chapters, that is from chemistry chapters. So we have completed now three chapters, that is chemical reactions and equation. Then we have completed acid bases and salts. Then carbon and its compound. Okay, so today we are going to start with a new topic, that is metals and non-metals. Okay, so shall we start? So here we are going to discuss with the important concepts. Okay, we are going to deal with the important concepts in today's class. So which are the important concepts from this particular chapter? So those things we are going to deal. Okay. So you have seen the periodic table, students, right? You have seen the periodic table, right? Okay. So our periodic table. So there are so many elements in the periodic table, right? So there are so many. So till date we know that there are 114 elements, right? We know what 114 elements. Just a second. Give me 1 minute. Fine. Okay, so we'll start now. Okay. So we know that you have seen the periodic table. So in periodic table, there are 118 elements, right? Till like in the till now, we know that there are 118 elements, right? So how these elements are classified? So these elements are classified as metals, okay, and non-metals. How? Depending on their properties, right? We know that, so there are 118 elements, and these elements, okay, it is very difficult to study individually. So they are classified based on their physical and chemical properties, based on their periodicity, right? So the elements which are belonging to same period, same same family, they are put up in a particular group, right? So here elements. So these elements, they are basically classified as metals and non-metals. So depending upon their properties. Okay. So here in this particular chapter, we are going to see the properties, okay, of the metals and non-metals. Fine. So what are the physical properties of metals? So firstly, we are going to see the physical properties of matter. Okay. So the first one is metallic cluster. So first property is metallic cluster. Okay, that is metallic cluster. Okay, so what do you mean by metallic cluster? So the pure state of a metal has a shiny surface. So you have seen most of the metals. Okay, most of the metals. So these are having a unique property of having shine. Okay, so these metals, they have a shiny surface. So because of the shiny surface, okay, the metal is said to be what having a property which is called as luster. Okay, it is called as luster. So pure state. So whenever the metals are in their pure state, so they are said to be having a shiny surface, and this property is called as metallic luster. For example, take coins. Okay, the coins. So these coins, okay, the your denomination, okay, so the coins, so you have seen the coins, how they have shine, okay, because they are metals, okay. Now The second property of metals, they are hard. Okay, when you see the metals, most of the metals, they are hard. Now, when we see the periodic property, okay, so in the, sorry, periodic table, so where are these metal placed? Okay, on the left side, so the first group and the second group, okay. So these are what? These are metals, okay. So the mostly the first group, okay. So these are the alkali metals. So metals are hard, but alkalis are soft. Okay, so alkali metals, they are soft in nature. They are very soft in nature, and these metals can be cut. How they can be cut? With the help of a knife. So by making use of knife, you can cut this particular metals. Okay. Okay, so metals, they are hard. So all the metals, they are having a unique property, or that is a physical property. They are very hard. But the alkali metals, they are very soft. For example, sodium. You might have seen sodium, working with sodium. So when you are cutting the sodium, so sodium is preserved in kerosene. Okay, and this sodium is very highly reactive. So it is placed in kerosene. So how it has been cut? It is the sodium, it can be cut with the help of knife. Okay, so so the examples of metals, okay, being hard is the steel bridges. Okay, the bridges which are made up of steel, how they are very hard, right? Then the vehicle axle, so the axles of the vehicles, okay, so they are also very hard, so that is made up of metals. Okay, so these are the properties. So we have seen two properties. Third is malleability. What do you mean by malleability? So metals can be converted into thin sheets. Okay, so metals, when the conversion of metal, okay, the raw metal into the thin sheets. Okay, so this property is called as malleability. For example, plates, for example coins, okay, for example the sheets. Okay, so these are made up of, they are beaten, okay, they are beaten and they are made to like into a thin sheets. Okay, so this property is called as malleability. Okay, this property is called as what? Malleability. Okay, next is what? Ductility. So another unique property which is shown by the metals is ductility. Ductility means what? These metals can be converted into wires. Okay, so when the metals, when they can be converted into wires, then they are called as what? They are called as metals. When it can be drawn into thin wires, this property is called as ductility. For example, the wires, nails, bars, railway tracks. Okay, so these are what? These are the what? The example. Okay, these are the examples of ductility. Okay, so when you see the wires, okay, so metals, so most of the metals, the wires, for example, the copper wires, okay, the wires which we make use for the electricity. Okay, so these wires, they are made up of copper. Copper is what? Copper is a metal, right? Then the nails, you have seen nails, how those nails, okay, so nails are also so these nails are also they are coined into thin this wire-like shape, right? Then the bars, okay, the bars which we are using for the windows, okay, for the gates. So those bars are also coined up in like the thin wires, okay. It means a bunch of wire when they are made into, so they are coined into a long bars, okay. Then the railway tracks. So railway tracks also, in between you can see rod like you require long wire like rods, right? So these are also coined into thin wires like shape. Okay. So this is property called ductility. So remember that only metals can be converted into thin sheets and thin wires. So when it is converted into thin sheets, the property is called as malleability. When the metals are converted into thin wires, then this property is called as ductility. Okay. So remember these things. Fine. Next, these metals are good conductors of heat. Okay, these metals are good conductors of heat. So, okay, metals, they allow heat to pass through them easily. We know that metals, they allow heat to pass through them easily. Okay, for example, the cooking utensils. Okay, cooking utensils, they are made up of what? They are made up of metal, right? So they allow the passage of heat through them so that the food is cooked properly, right? So metals, they are good conductors of heat. Okay. So this property is called as thermal good conductor. Then the iron box coil. So some of the box, okay, iron box coil. So it is made up of iron. So this also acts as a good conductor of uh, okay, good conductor thermal of heat. Fine. Then metals also act as good conductors of electricity. Okay, metals, they act as good conductors of electricity. For example, for the supply of electricity, okay, the wiring, how it is done? With the help of metal. Okay, so to pass the current easily, okay, so metals are used. So which metal is used? Copper metal. So metals allow the passage of electric current through them easily. And this property is called as that is electrical good conductor. Okay, for example, the electrical wire. Fine. Next is metals are sonorous. What do you mean by sonorous? They are having the property of producing sounds. Okay, so these are having the property of producing sound. So this property is called as what? Sonorous. This property is called as what? Sonorous. Fine. For example, making bells. So the bells, okay, that is making bells, how they produce sound. For example, the utensils also, okay, so they produce sound. So metals, most of the metals, they produce sound. So because they are producing sound, they are called as, the term is given as sonorous. What the term is given as? The term is given as sonorous. Okay, so remember this. Okay, so the word which is used for the that is for producing sound. Okay, the metals are capable of producing sound, and this property is called as sonorous. Okay, producing sound means this property is called as sonorous. Fine. Now, what are the exception in physical properties? So there are some metals, that is, it is not that all the metals are showing these properties. Okay, so there are some exceptions, some metals and non-metals. Okay, which are having some exceptional property. Okay, they do not follow these category of metals and non-metals. Okay, then what is the exception in physical property, students? Yes. So iodine, okay. Iodine, it is lustrous. Okay. The exceptional properties, iodine, okay, it is a non-metal. Iodine is a non-metal and it is lustrous non-metal. Okay, lustrous means what? It has a shiny surface. So iodine, okay, it is not a metal, because we know that metals are only lustrous, okay, and they are having shiny surface. But here is an exception where metal, your iodine is a non-metal and it is lustrous. Okay, it is having a shiny surface. Then, for example, second is mercury. Okay, as we have stated that most of the metals are hard. Okay, your mercury is a non-metal, which is a liquid metal. Okay, it is a mercury is a liquid metal. Okay, the state of this mercury is, it is a liquid metal. Then gallium and cesium. So gallium and cesium, okay, so these are the metals which are low boiling and melting point. Okay, so these are having low boiling and melting point. So most of the metals, they are having high boiling point and high melting point. But this gallium and cesium, they are having low boiling and melting point. Then lithium, sodium, potassium. So these are all alkali metals. Okay, and these are very soft metals. Okay, with very low density. Density is nothing but mass by volume. It is having very low mass. Okay, so metals can easily be cut with the help of knife. So because of the because the density is very low, because okay, because of this character, they are very soft in nature, and thus these metals cut with the help of the knife. It is a allotrope substance. Okay, so this is a hardest natural substance. Fine. Next is graphite. So graphite is also another allotrope of carbon, which is a non-metal with a good conductor of electricity. Why they are good conductor of electricity, student? Graphite, because here the carbon atoms, okay, they are bound to other carbon atoms with a double bond, because it is a sp2 hybridized. Okay, here the carbon atoms, they are sp2 hybridized Because of that, what is happening here? Here there will be one electron, unpaired electron will be present. Because of this unpaired electron, the metals they can conduct good, that is, they can conduct electricity. Okay. But we know that carbon is a non-metal. But still, carbon being a non-metal, it is a good conductor of electricity. Okay, so this is an exceptional cases, okay, of some of the metals and non-metals. Now we have seen here the physical properties of metals. Okay. Now, what are the physical properties of non-metals? As we know that metals are having a shiny surface, non-metals, they do not have a shiny surface. Okay, they are do not have a shiny surface, so these are non-lustrous. Okay, then metals are hard, non-metals are, they are not hard. Okay, they are soft in nature. Okay, then malleability and ductility. So most of the metals, they show the property of convert, if they are converted into thin sheets, then they are malleability. If they can be converted into thin wires, then the property is called as ductility. But non-metals, they do not show this property of malleability and ductility. Okay, so these are non-malleable and non-ductile. Okay, that is non-metals. Then metals, as we know, they are good conductors of heat and electricity. Non-metals, they are bad conductors of heat and electricity. Okay, on the other hand, metals are good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity. Then metals are sonorous. Okay, they can produce sound. Non-metals do not produce sound. So they are called as non-sonorous. What they are called as? They are called as non-sonorous. So these are the physical properties of metals. And we have seen the exceptional cases of some of the metals and non-metals. Okay, so they show the reverse properties. Okay, some of the properties are unique. Okay, now there's something called as amphoteric. Now, so we have studied now what are metals. Now we have studied what are non-metals. Now, what do you mean by amphoteric, students? Amphoteric means what? So amphoteric means what? So either they react with acid and they can react with base. Okay. So so there are some of the metal oxides. Okay. Now what is amphoteric nature? What is amphoteric nature? Okay, so there are some metal oxides. Now, how these metal oxides are formed? When metals react with oxygen. Okay, when metals react with oxygen, what they form? They form metal oxides. Okay, they form what? Metal oxides. So there are certain metal oxides, for example, aluminium oxide. Okay, for example, zinc oxide. So these are amphoteric in nature. That is, they react both with acids as well as bases, and they produce salts and water. Okay, so there are some of the oxides which react with both acid as well as bases to produce salts and water. And thus these are called as what? Amphoteric oxide. These are called as amphoteric oxide. So you can see the example Al2O3 plus 6HCl giving you 2AlCl3 plus 3H2O. Okay, so this is the amphoteric oxide. Okay, so some metal oxide you can see such as the aluminium, zinc oxide, when they react with both acids as well as bases, then they can produce salts and water, and they are known as what? Amphoteric oxides. Okay, these are the examples. These are the examples of such. Okay, so now next is the properties of ionic compound. Now, what are ionic compounds? Okay, so in ionic bond formation, okay, so there will be transfer of electron takes place. What happens? Transfer of electron takes place. So one atom can either take the electron, another atom will give the electron. So there will be transfer of electron takes place. Now, what is this called as ionic compound? Okay, so the compounds wherein the transfer of electron takes place. For suppose I take NaCl. Okay, so this is an ionic compound. So this is what? This is sodium chloride. Okay. So what does sodium do? Sodium will is having one electron in its outermost shell so that it will be more stable. So when it gives this one electron, it will be in its stable state. On the other hand, when chlorine, it wants one electron so that its outermost electronic configuration can be completed. Okay, so chlorine will take this one electron. So this will give and this will take. And thus Na plus and this will be Cl minus. Okay, so it forms what? They form a ionic bond, that is NaCl. Okay, so these are ionic compound, that is share transfer of electron takes place. So sodium will give electron, Cl will take the electron. Okay, Cl will take the electron. Fine. So this is about ionic compound. Next, what is the physical properties of ionic compound? Okay, so that is they are solid and they are hard. These ionic compound, they are solid and they are hard. Why? Due to the interionic forces of attraction. So due to the presence of interionic forces of attraction, okay, these ionic bonds, they are okay, because of this interionic forces of attraction, the compounds are hard and they are solid and they are brittle. Okay, these compounds are generally brittle in state. Okay, now what about the melting and boiling point? Okay, what about the melting and boiling point? So they are having high melting and boiling point. Why? Because there is considerable forces required to break the strong interionic forces of attraction. Because one is plus, another is Cl minus. Okay. So there is a strong interionic forces between these ions. So this is a cation, this is a anion. So there is a strong force which is applied so that so strong force should be applied for the separation of these ions. Okay. So to break this bond, okay, that is they require okay. So more forces applied. So because of this, the boiling and the melting point of these compound, they are very high. Then when we see the solubility, when we consider the solubility of ionic compound, most of the ionic compound, these are generally soluble in water. Okay, these are generally soluble in water, but they are insoluble in organic solvent. These are insoluble in organic solvents. Okay, such as which are the organic solvents like kerosene, petrol, etc. Okay, so these are the organic solvent where they are insoluble. Okay. Fine. Next is conduction of electricity. Okay. Now, what about conduction of electricity? Will it conduct electricity? Yes, because they involve charge ion. Because it involve charge ions. So, because Na plus ions and Cl minus, right? So, these are charge ions. Whenever charge ions are present, there can be possibility of conduction. So, it can involve electricity, conduct electricity. Suppose I add NaCl into water. Okay, I take a beaker, I take water, and to that I add NaCl. Okay, what will happen? This NaCl, when we add in water, it get ionized. Okay, and it forms Na plus and Cl minus ions. Okay, now these ions, when okay, if you supply electricity here, okay, then the charge, they will start conducting electricity. Okay, because of because it involves the movement of involvement of these charged ions or charged particles. Okay, so because if you take a solid NaCl, okay, so the conduction of electricity is only possible in molten state. Okay, that is it is only possible in molten state. Okay, so as movement of ions is not possible in solid state because of the rigid structure, they do not conduct. So NaCl, okay, ionic compounds when they are in solid, they do not conduct. But when they are in molten state, Okay, they conduct electricity. Okay, when you add NaCl in water, because of the dissociation of these charge ions, okay, it will start conducting the electricity. Okay, so this is about the properties of ionic compounds. So very important. So these are the important concepts which I am going through. Okay, next is the reactivity series of metals. So as we know, so what is reactivity series of metal, students? What is this reactivity series? Yes. So in reactivity series, okay, the metals, they are arranged in the order of their decreasing activities. You can see these metals here: lithium, sodium, lithium, potassium, barium, sodium, calcium, magnesium, aluminum, zinc, iron, nickel, tin, lead, then hydrogen, copper, mercury, silver, gold, and platinum. Okay, so these metals, they are arranged in the order of their decreasing activities. Okay, so after performing some displacement experiments, okay, this following series is been set up, okay, has been developed. So these are called as reactivity or activity series. So this potassium, lithium, okay, this is most reactive metal. Okay, so that is a potassium, sodium, then calcium, then your magnesium, aluminum. So as you go down, what will happen to reactivity series? It goes on decreasing. So the reactivity series is highest here and it is lowest at the bottom. And slowly it goes on decreasing reactivities. And if you go from bottom to top, the reactivity series goes on increasing. Okay. So how to okay, how to remember these series? So you can keep this in mind. Okay, please start calling me a zebra. Instead, try learning how copper saves gold. Okay, so this particular sentence, by hearting this particular sentence, you can uh, okay, you can keep this in mind. So please, P means potassium, S means sodium, C means calcium, M means magnesium, A means aluminium, Z means zinc, I means iron, T means tin, L means lead, H means hydrogen, C means copper, S means silver, G means gold. Okay, so you can keep this line in mind. Okay, and you can write down the reactivity series of these particular metals. Okay, okay. So gold, silver are the least reactive. Then potassium, sodium are the highest, or they are the most reactive of okay, reactive of all the metals. Fine. So these are the reactivity series. Now next we are going to see is the extraction of metals. Okay, next is what? Extraction of metals. So extraction of metals low in the activity series. Okay, so that is these metals are generally very reactive. Oxides of these can be reduced to metals by heating alone. So the metals, so when we are extracting the metals which are having low reactivity series, okay. So what will happen that time? So that time, so these whenever we are taking the metals which are of low reactivity series, so these metals are highly unreactive. Okay, they are very unreactive. So the oxides of these oxides of these can be reduced to metals. Okay, we are taking the oxides of these and they can be converted into metals by heating alone. By heating alone. For example, if I take Zn, that is HGS. Okay, HGS. When you react it with oxygen and supply heat, you get HgO plus SO2. Okay, mercurous oxide. So like this. So it can be converted all over. Fine. Now, whenever you want to extract the metals from the middle of the activity series, okay, which is the middle activity series. For suppose if I want to extract aluminum, zinc, iron, tin. So these are the elements which are in the middle. Okay, so that time what you can do? You can either, okay, you have to it, it's easy to obtain the metal form, okay, from its oxide compared to its sulfide and carbonate. So it will be very easy. So if you want to extract the metal from the activity series from the middle, so it can be easily, you can obtain the metal in its oxide form compared to its sulfide and carbonate. So there are two processes for conversion of sulfide ore into oxides. Okay, it is called as roasting. Okay, it is called as roasting, wherein we are converting the sulfide ores into oxides by heating strongly in the presence of excess of air. So when we supply, so whenever you have sulfide ores, okay, and when you supply more amount of heat, okay, so in the presence of this air, okay, what will happen? The sulfide ore can be converted into oxides. Okay, so this is the what you say, this is called as roasting. This is called as what? Roasting. That is 2Zns, okay, zinc sulfide solid plus oxygen gaseous form, giving you 2ZnO solid plus 2SO2 gaseous. Okay. So this is the reaction wherein we are converting the sulfide in the presence of excess of oxygen, and after heating it we are converted into its oxide form. Okay, so this process is called as roasting. Next is calcination. So what is done in calcination? So calcination is a process in which our carbonates, okay, is converted into oxide ore. It is converted into oxides. How? Again, by supplying air, but in the limited form. We are heating by supplying the air in the limited form. Okay, we are converting the carbonates into oxide. So what is calcination? It is a process wherein we are converting the carbonate ores into oxide by heating strongly in limited air. So that is ZnCO3 solid giving you ZnO plus carbon dioxide gas. Okay, so this is the what reaction. Okay, fine. Now, what is thermite reaction? What do you mean by thermite reaction? Give an example. So please make important note of these questions. Okay. So what is thermite reaction? So reaction of metal iron oxide. Okay. What is iron oxide? Fe2O3. So the reaction of iron oxide with aluminium, which is used to join the railway tracks or cracked machine parts. Okay. So this is called as thermite reaction. So Fe2O3 plus 2Al giving you 2Fe plus Al2O3 plus heat. Okay. So this is the reaction which is called as a thermite reaction. What it is? It is called as thermite reaction, wherein we are using this reaction for joining the railway tracks or cracked machine parts. Okay. For joining the railway tracks or cracked machine parts. Fine. Now, next is we are doing the extraction of metals, okay, when they are high in activity series. So for example, potassium, sodium, okay, so these elements when you want to extract, so what is the procedure? So since this elements, okay, or since these metals are highly reactive, so those cannot be obtained by displacement reaction. Okay, so these metals should be obtained by electrolytic refining. So as these are highly or these are most reactive, so we cannot extract by using the displacement reaction. So we have to use electrolytic refining. So what is done generally, it is obtained by electrolysis of their molten chloride. So the metals will be in their molten state, that is in their chloride forms. So by performing the electrolysis of these molten chlorides, the what will happen, the metals will be getting deposited at the cathode, which is negatively charged, while the chlorine will be liberated at the anode. So this is the reaction. So at cathode, Na plus electron give you Na. Okay, so this is gain of electrons. So reduction is taking place here. And what is oxidation? Loss of electron. So at cathode, this is anode. Okay, so at anode, reduction oxidation is possible, and at cathode reduction is possible because there is a gain of electron and here there is a loss of electron. So this is the method of extracting the metals in their high reactivity series or high reactivity series. So by this method, you can obtain the aluminum, okay, from its aluminum oxide. So aluminum oxide, you can do electrolytic reduction or electrolytic refining, and from that you can obtain your aluminum. Okay. Next is prevention of, yes. So next is prevention of corrosion of irons. Okay. Next is what? Prevention of corrosion of irons. Okay. So how you can, what is corrosion? First of all, what is corrosion, students? Yes. What do you mean by corrosion? What do you mean by corrosions? Can anyone tell me what is corrosion? What is corrosion? Suppose I give you the example of your gate. Okay, the gate which is in front of your home. Okay, so that is made up of what? It is made up of iron. Why do you paint it? So when you set up a new gate, okay, when you set up a new gate, this gate is, it is made up of what? It is made up of iron. Okay, it is made up of iron, right? It is made up of what? It is made up of iron, right? So, uh, if we keep the iron gate exposed to air and moisture, what do we mean by moisture? Water. Okay, rain will be falling. Now there will be air in the environment. Okay, in air, oxygen, other this will be present. Okay. Now these air components, what they will do when they come in contact with the iron, okay, of the gate. So what will happen? It will start getting corroded. Okay, it will start getting corroded, or it is called as rust. Okay, there it forms a rust. Okay, so the iron start getting rusted. So what is happening there? Your iron metal is converted into the it contains Fe2O3 dot X water molecule because it comes in contact with the moisture and air. It comes in contact with the moisture and the air. Okay, so because of that, your iron, the metal iron, is converted into if this, okay, that is ferric oxide, hydrated ferric oxide. Now, how these corrosion can be prevented? First thing, what you can do, the gate, okay, you can paint it. Okay, if you apply paint, then there is no possibility of coming in contact with moisture and air. Okay, so the iron can is, it is prevented from rust and corrosion. Then by applying grease, okay, if you apply grease also, the corrosion can be prevented. Then there's something called as galvanization. What do you mean by galvanization? It is a process of protecting steel from and iron. Okay, it is process of protecting steel and iron from rusting by coating them with the thin layer of zinc. So when you, if you take iron or sometimes the steel, okay, so to prevent the rusting, what you can do, you can coat these two with the thin layer of zinc. You can coat these two with the thin layer of zinc. So this process is called as what? Galvanization. This process is called as galvanization. Okay. Next is chromium plating or thin plating. There's something called as chromium plating and thin plating. Okay. So by this also you can do, you can prevent your, this what? Corrosion. Okay. You can prevent the corrosion, that is rusting of iron. Then alloying. Okay. What is alloying? That is improve the properties of metal. So what do you mean by alloys? What do you mean by alloys? Yes, when two or more metals or non-metals when they combine. Okay, so this property is called as alloy. So by alloying, that is by improving the properties of metal. Okay, so you can prevent your corrosion of iron. Okay, is it clear, students? Is it clear? Whatever the things is told, is it clear till here? Okay. So yes, Sivadama has okay. There's a question. What is thermite? Why is thermite reaction useful for welding rails? Now you know that. Okay, so thermite reactions are what they are mostly used where they are used in the railways. Okay, for the welding purpose. Now you have seen the railway tracks, right? So to join the tracks together, okay, to weld the rail together, their thermite reaction is used. Okay, so that time we are making use of these thermite welding. What is happening in thermite welding? Thermite welding, it will produce high temperature. Okay, by using this reaction, it produces high temperature so that your steel, okay, because you know that the tracks are made up of steel. Okay, these steel, it can be melted. Okay, it can melt the steel so that it allows a very strong connection between the two rail sections. Okay, so that it can be joined together. So this is nothing but your thermite reaction. So thermite reaction is very used. So it is widely used in rail only. Okay, railroads, for railroads only. Okay. So this is the use of thermite reaction. Fine. So next is alloys. What do you mean by alloy? As we have discussed, alloy is a homogeneous mixture of metals and two or more other metals or non-metals. Okay. So these are some of the alloys. Okay, these are some of the alloys. So steel, what is the composition of steel? 99% iron and 1% carbon. What is the properties? It is very hard and it is very strong. So where we make use of steel? So steel, it is used in construction of building, then for bridges, okay, and railway tracks. There we make use of this steel. Okay, so steel, it is a alloy where we are making use of iron, okay, and 1% carbon. Then next is stainless steel. What is stainless steel? Stainless steel, the composition is iron, nickel, and cobalt. Okay, what is the property? It has a shine, hard, they are very hard, they are strong, and they do not rust. Okay, where we use stainless steel, we make use in cooking utensils for, okay, for cooking purpose, we make use of the stainless steel. Then for surgical instruments, okay, whenever the surgery processes are going on, the first example, the dentist, okay, dentist use different dentist equipments, okay, for surgicals, and also these are all made up of stainless steel. Then brass, what is brass? It is a alloy which is made up of copper and zinc. Okay, these are more malleable, it can be converted into thin sheets, and they are more stronger than pure copper. Then uses same brass is also used for cooking purpose, that is for utensils and musical instruments. The next is bronze. Bronze is so please remember the alloy and its composition. Uses, okay, very important. Brass, it is made up of, bronze is made up of copper and tin. It is very shiny, it is hard, okay, strong, and it also does not rust. Okay, shiny, hard, strong, and do not rust. So, where bronze is made in making statues, okay, coins and medals. So, bronze is used. Next is solder. Solder, the composition is tin and lead. So, the property, it is having low melting point. It is used in welding electrical wire together. Next is amalgam. Amalgam in any alloy of mercury with one or more other metals is called as amalgam. So any alloy of mercury, okay, with one or more other metals, they are called as amalgam. Then, for example, sodium amalgam, okay, NaHg. It is a restorative, that is toughness. So it is a restorative and toughness. So this is a property. Then where it is used by dentist for filling the teeth. So if there is some decay when they do the digging, okay. So for filling up the teeth, they use amalgam. Next is alloy of gold. What is alloy of gold? Either gold and silver or gold and copper. So properties, these are harder than pure gold. Where it is used in making gold ornaments. Okay, is it clear? Okay, so please go through these diagrams. Okay, please go through these diagrams. So in next class, I'll be telling about this. So these diagrams are very important for, okay, you can see these three diagrams. The first one is action of steam on a metal. Okay, so you have to practice this diagram. Next is testing the conductivity of a salt solution and electrolytic refining of copper. Okay, so these are very important. Is it clear? So are the concepts clear, whatever has been told? Any doubts? Okay, fine. Okay then, if you have any doubts, you can ask me. So this was about the important concept from this particular chapter, that is metals and non-metals. So go through these important concepts, which are very important. Okay. So based on these only, the questions can be asked. So in the next class, I'll be solving the important questions from these particular chapters. Okay. Fine. So if there is no doubt, so I shall end the session here. So we'll be meeting in the next class. Fine. So thank you, dear students. So we'll meet in the next class.